All right, here we go. Make sure you have paper and pencil out to take some notes. So this lesson is called Imaginary Numbers. Right? So just like what you're thinking about, imaginary numbers are numbers that don't exist, right? They're imaginary. Some mathematicians years ago decided to make imaginary numbers to fit certain criteria that just wasn't matching up. So let me get started. So here. So we know this is the square root symbol, right? So we know that the square root of 1, right? The square root of 1. So the question is, what two numbers multiply with each other to make 1? The square root of 1 is 1, right? We could do it with several numbers. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5, and so on, right? You guys have learned that for a while. So we know that the simple is 1. The square root of 1 is 1, right? So if that's the case, I have a question for you guys. Right? It says, so then, if the square root of 1 is 1, so then what is the square root of, let me zoom in here. What is the square root of negative 1? What is the square root of negative 1? So I want you to think about that. So the square root of 1 is 1. What is the square root of negative 1? You're probably thinking negative 1. So let's try. Negative 1 times negative 1, that gives you positive 1. So nope, that's not it. The square root of 1 is 1, so let's see. Let's try. 1 times 1 is positive 1. That doesn't work either. 0, no. 0 times 0 is 0. That doesn't work. So this is the dilemma that mathematicians came up with. There is no square root of 1, right? So what they did is this. They said the square root of 1 is I. The square root of 1 is I. I know it looks like a little backwards J, but don't worry, that's 1. So the square root of 1 is I. It's imaginary. It's an imaginary number. There are no two numbers that multiply by each other to give you negative 1. The square root of 4 is 2, right? 2 times 2 is 4. The square root of 25 is 5 times 5, right? The square root of 49 is 7 times 7. But there are no two numbers that will multiply to give you negative 1, right? So the square root of negative 1 is I. It's an imaginary number. So let's remember that we have a square root. What is the opposite of a square root? How am I going to get this negative 1 out of here? Out of this square root? Well, the opposite of a square root is a square the power of 2. But remember, this is an equal sign. That means whatever I do to the left, I have to do to the right. So if I put a power of 2 here, that means I have to put a power of 2 here as well. So to the power of 2. Now look what happens. This square root and this square are opposites of each other. And just like positive and negative cancel out, multiplying and dividing cancel out, square roots and squares cancel out. So this square root cancels with this square. So look what comes down by itself. -1 comes down, right? So I get -1 is equal to, this is just I squared, I to the power of 2. So -1, so I squared is equal to -1. So wherever you see I to the power of 2, you're going to cross it out and you're going to write -1. But there are some other i's that we can replace as well. And let's check those out. So let's I multiply, right? Get it? I multiply, iPhone, iPad. Sorry, lame attempt at a joke. Okay, so I. So what we do know is that I to the power of 1 is just I, right? Just I. Do a better that part about with that I. I to the power of 1 is just I. So whenever you see I, just I, right? So what about these two here? I remember parentheses means to multiply, right? So this is I times I. So I times I is I squared, right? It's two i's. I times I is I squared. Well, remember that I squared is -1. So I squared becomes -1. So that's that, and that's that. So I to the first is I squared is -1, right? So let's see what else we have here. So now we have 3 i's. So remember, 2 at a time only, always 2 at a time. So let's do these two. So I have I times I is I to the power of 2. So I have that. And I still have this other I that I'm going to bring down. Well, that's easy because I already know what both of those are. I squared is -1. So I'm just going to write here -1, parentheses. I by itself, well, that's just I, see? I to the power of 1 is just I. So this is I. Well, what is -1 times I? Right? -1 times I is -I. Just like that. -I. So 3 i's, I to the power of 3, is equal to -I. I to the power of 2, 2 i's, is equal to -1. And just 1 I is equal to I. Right? So, last one here. So let's see what we have. 2 at a time, remember? I times I is I squared. Well, check it out. I have another 2 i's there, and that also gives me I squared. Well, I already know what I squared is. I to the power of 2 is -1. So that means that both of these are -1 and -1. And what is -1 times -1? Well, a negative times a negative is a positive, and 1 times 1 is 1. So there you go. Look at that. I to the power of 4. Oops. 4 i's, I to the power of 4 is positive 1. I to the power of 3 is negative I. I to the power of 2 is negative 1. And just I is I. Right? That's a lot of information. So let's make ourselves a little key. This is the key that you guys are going to use for your notes. So here it is right here. Look. Our imaginary key. So let's start. I to the power of 1. Well, that's just equal to I. That's it. Right? Here it is right here. I to the power of 1 is just I. Right? What's next? I to the power of 2. Well, how much is I to the power of 2? We did it right here. I to the power of 2 is negative 1. So, I to the power of 2 is negative 1. So what's next? I to the power of 3. Well, how much is 3 i's? Oh, we did it right here. Right? 3 i's right here. And what did we get at the end? Negative I. So I to the power of 3 is negative I. And finally, I to the power of 4 is, it was right here. 4 i's gives you 1. So I to the power of 4 is 1. Let me put that little symbol here so I'm not confused. Now these are our 4 key i's. Okay? These are the i's that we're going to use to do all the work with imaginary numbers. This is our key. I to the power of 1 is I. I to the power of 2 is negative 1. I to the power of 3 is negative I. And I to the power of 4 is 1. Now I want to highlight this one here. This is our special one. Actually, that's too dark. Let me use this is our special one right here. This is the key. See? This 4 right here is the key. And I'm going to show you. I'll show you. Let's go to this part of the notes now. So, our first part of these notes here says divide. Do a little smaller here, orange. Divide numbers bigger than 4 by 4. You'll understand what I mean about that in a second. Okay. Next, the remainder is your new I. It's your new I. Okay. So, step 1. Divide numbers bigger than 4 by 4. So you see this first example here. This 46, that's bigger than 4 for sure. So I'm going to do some old school division. And I'm going to divide by 4. 4 goes into 46. How many times? Well, 4 into 1 goes 1 time. 4 times 1 is 4. 4 minus 4 is 0. I bring down my 6. How many times does 4 go into 6 without going over? 1 time, right? 1 times 4 is 4. And 6 minus 4 is 2. That's where I want you to stop. Okay? I want you to stop there. Because 4 doesn't go into 2. That's where I want you to stop. Right? Now, this is my key here. This 2. Everybody see this 2? That is our remainder. And what does it say here on the notes? Remainder is your new I. Remainder is your new I. That means that this problem right here, I'm going to rewrite it as I to the power of 2. And this is where I got this 2. See? I to the power of 2. That's my new I. And what does I to the power of 2 mean? Well, let's check our key again. What is I to the power of 2? I to the power of 2 is negative 1. So this answer right here evaluates to negative 1. And that's the answer right there. That is the answer right there. You'll get it. Don't worry. We'll practice and you will understand it. Okay? The key is I divided by 4, right? And my remainder became my new I. I transformed this I-46 to I to the power of 2. Because you see this I to the 46? That's not on my chart. That's not on my key here. I need to do one of these 4. Because one of these 4, I know the solutions. Right? I know the solutions. So, let's do the second example. So here you see, I see 2 things. I see 2 i's. I to the 6 and I to the 25. So we will remember that when you multiply and the 2 bases are the same, when we multiply and the 2 bases are the same, meaning the i's are the same, that means that I can add 6 plus 25. So 6 plus 25 gives me I to the 31. Now, is that 31 bigger than 4? Of course it is, right? So we're going to do some old school division, and we're going to divide 31 by 4. So, can 4 go into 3? It can't. Can 4 go into 32 without going over? It can. So, use your calculator. How many times does 4 go into 31 divided by 4? You're going to get 7 point something, right? The 7 is what matters here. 7. So, 4 times 7 is 28. I subtract. 31 minus 28 is 3. This is my key right here. The remainder. The remainder is my key. The 3. So now look what I'm going to do. This I to the 31 is going to become I to the 3. This is where I got the 3 from. This 3 is that 3. So now I can say I to the power of 3, right? This I to the power of 3 is equal to what? Well, I have my key right here. How much is I to the power of 3? Negative I, right there. So this gives me negative I. And this is my solution. I evaluated I to the 6 times I to the 25, and my final answer was negative I. Negative imaginary number, right? So those are the two examples. Let's do one more example right here. This one. This one looks complicated, but it's okay, right? Remember, let's use our calculator. So here I have 4 different i's. I. They're all I. So that means that I can add 18 plus 24 plus 27 plus 16. So I'm going to do it on my calculator here. 18 plus 24 plus 27 plus 16 is equal to 85. So these two, these 4 i's gave me I to the 85th power. Now ask yourself, is that 85 bigger than 4? Of course it's bigger than 4, right? So we're going to take 4 old school division divided by 85. So let's do some old school division. How many times does 4 go into 8? 2. 2 times 4 is 8. I subtract. 8 minus 8 is 0. I bring down my 5. How many times does 4 go into 5? 1. Right? 4 times 1 is 4. 5 minus 4 is 1. This is my key number right here, because this is the remainder. This is the remainder. So my I to the 85 became I to the power of 1. This 1 comes from there. Right? So that means that my answer is I to the power of 1. I go back and check my key. I to the power of 1 is just I. So my answer here is just I. And that is my solution right there. So I know this is different, and I know this is more complicated than you've done before, but with practice, right, you will be able to do these in no time.